And I will try to go very fast through the presentation so we can have a little space for a demo at the end of the presentation, and then you will be also in the dangerous demo around noon. And so we'll cover difference between SIP calls, video calls, and conferencing, and how all the pieces fit together. The concept is we want to have a modern and rich environment where with all the bells and whistles, but we want it to be scalable and to reuse all our infrastructure, all our investments in knowledge and infrastructure. So we will see that we will use standard technologies adapted to the web time and to our age. Aim, a modern, reachable from any kind of clients, and that's very important too, to be usable from low-powered, low batteries, low CPU devices. So that is not required to have a smartphone with octa cores in the last generations. SIP has got video calls since ages, but we need much more than video calls. We need management, we need the moderator, we need to mix and match the different audio-video streams and composite them together, and have interaction with the backend and with the system at large. So we will use FreeSWITCH as our media server and application server because it gives us a tool set, a box full of tools that we can use to build our application. And we will see that we will use mostly dial plan, chat plan, the simple message processing, and the capability of FreeSWITCH both as MCU and as video stream switcher. WebRTC we will use as a transport and is there to stay because not only is used by billions of browsers, but it's also the base for all the Internet of Things streaming. So we're free to invent our own protocols because WebRTC does not mandate any kind of protocols, and but we have some complex needs. So to give us a complete environment that we can really put into production and have our people to interact in a secure, accountable, and modern way. This whole kind of infrastructure is given to us from SIP by free, because we know that SIP scales well, and we know how to manage the whole infrastructure, from switches to media server, to proxies, to trunking. And what we will use in details, we will use Kamailio as proxy for security, AAA, and dispatching to a farm of backend free switches. We will use a SIP simple, the message packet, to send back and forth commands and feedback between the system and the clients and the chat messages. And we will use FreeSWITCH B2B UA, the back-to-back user agent and application server capabilities to do all the media services, to process the simple SIP messages. And we will use on the client side SIP.js as a JavaScript library that implements SIP with all its best and wisdom. And then we want also to have an app for the smartphone, and an app that goes both on Android, on iOS, because you know there is people that use iPhone. And we want those phones not to be always on and draining their batteries, just doing options or keeping a TCP socket open. We want those phones to sleep, and we want our application not to run, definitely not to run. But when we send a call, we want that application magically awake. And we do that with push technology, with the infamous push technology, that actually it works. So we will see that. And we will see that when we send an invite, in the meantime, we also send a push to Google. Google then distribute both to Android and iOS smartphones. And in that way, the application that we have on the smartphone will wake up thanks to the push mechanism. And that application we will make with exactly the same HTML and the same JavaScript that we use for the website. So we will have the browser and the application generated from exactly the same code. We will use Cordova as a mechanism to build the application. Cordova is, all the things that I'm talking about is all open source, all is available. This is our general structure, is very well known, so I will not go into details. It's the whole enchilada, so the clients, the signaling, the media, our Kamailios in active-passive, RTP engine, the FreeSWITCH farms, and then the backend with the database and file systems. Kamailio configuration is, you can find a lot of example in the internet about how to do it with WebRTC. Then you combine with the load balancing and the NAT traversal and the RTP engine management. So you can dispatch on the backend FreeSWITCH farm, keeping registrations on the Kamailios. And so Kamailio will manage mainly register, invite, and message kind of packets. And possibly, it's not yet implemented, but I will do shortly, also the publish, subscribe, and notify in a way that we can also have blinking lights on the client application. What we need hash destination. So we want that the participants for the same conference goes into the same backend box, because we must mix and treat their streams together, so they need to be physically on the same machine. And this is very easy to do with Kamailio. We just take note of where we put the first call to destination, and then for the same destination, we bypass the dispatch algorithm and go straight to that same box. FreeSWITCH use all the free switches on the back end, use Kamailio as an SIP output proxy. And so we can maintain the registration mainly on Kamailio, and we will route back the calls, and we'll blindly accept both the registration and calls coming from Kamailio. So the authorization will be done by an ACL with Kamailio address. And we have three kinds of conferences, audio-video conferences, same thing. In FreeSWITCH, there is no difference between audio and video conferences. And we have three ways of doing it: in pass-through, in transcode, and MUX. Pass-through is the lowest possible CPU usage, and it just moves packets back and forth, and this actually is 0 CPU. But obviously, it cannot transcode. It just moves packets. So if you have RTP in VP8 on one channel, all the channels will get VP8. And so this can give problems because, you know, those kind of phones, the iPhones, do not support VP8 on Safari, for example, because. And so we need to do the transcoding H.264 to VP8 and back. And we can use the second lowest CPU usage, that's transcode, that only move packets, but it can transcode. Then if we want to give a high-hand service, if we want to do something that is a premium, we can use the MUX MUX kind of conferencing that allows us to use all the MCU features, so we can split screen, we can put captions, we can do computer graphics on it, and a lot of effects and magics and things like that. We will see all of that. Then we will configure also the conference command profiles that are just what kind of DTMF do what for participants. For example, the participants that calls through the PSTN and they only have a dial pad to interact with the conference. Chat plan. Chat plan is a FreeSWITCH dial plan for all that is chat. It's used by mod SMS that do not manage short text messages, but it just is an American way to name something that interfaces with the chat. And we will use it to process simple SIP messages, and this will give us a backbone to give commands and control back and forth from the clients to the server. And, for example, giving feedback, executing scripts, etc. So it will be used mainly to change the layout, to kick out someone, to mute, to give the floor, to change which stream is in foreground and which stream is in background, and things like that. An interesting feature of conferences in FreeSWITCH is that they can allow to broadcast all the SIP, all the chat messages, in our case, simple messages, that arrives to the conference extension and will be broadcasted to all participants. We use this mechanism to do the group chat and to do all the interaction between clients and conference. Conference clients can be from the normal phones and cell phones through audio calls to PSTN numbers. and from browsers and from the smartphone app that we build with Cordova. The audio, the pure audio calls from legacy phones will interact only with the TMF. SIP phones can also interact with programmable keys on the desk, on the material phone. Browsers will do all kind of things with all kind of gadgets, menu, click buttons, etc. And the smartphone app will have exactly the same things because it's the same code. So this is the interface, and you'll see you just do the login and enter. And now you can call, and there is a pre-set destination for the call to a conference. And you call it, and then you have your video going. And then, as you can see, you can type here your message, and we'll go into the group chat. Then this is the app on the phone. That's exactly the same. And this is the result when the app joined the conference. And this is when we open the controls button, and we can interact with all the conference things. So we have a list of participants, and we can give the floor, so the foreground, on a participant of our choice, mute the video, kick it out, hang up, and choose which kind of layout we have. For example, split screen, someone that is in the big monitor with all the little picture-in-picture around and things like that. And obviously we have screen sharing and the capability of going full screen. This is same thing saw from the cell phone, and there is a little bit of chatting back and forth. And let's see the push mechanism. So we have registered our client and server. The one client called the other, and you'll see that up there is the notification, and it will give you a sound like an incoming SMS or things like that. You check the notification, and you click in the notification, and you join the conference. This is the books on FreeSWITCH that I made. And we have time, some minutes for the, yes, okay. And so we will have a short demo.
Do you need a hand?
No, I think that I can manage. Okay, so you see that this is when you log in, and let's see. You can just write whatever here. There is actually is pre-authorized, and it's just to have a nice name when you do the chat group. And then let's call, and let's use the cell phone to join the same one.
Maybe I'll hold that.
This is actually an application made by Cordova, and And we actually are in a conference. And this is a conference that we can control, we can give the floor to which one we want. And so it's not so much interesting because we can do kind of very little things with this kind of conference, because this conference is the pass-through conference or the transcode conference. So we have no control on the nice things of MCU, but at least we can see. I have not installed here this I will show after with another browser, because I have the extension. And but let's do this, and let's kick out our app. Okay, the app is kicked out. And we hang up here. And let's call on the this one will go to the nice MCU. Okay. As you can see now, we are much nicer. And you see that there are dynamic captions, and we have, in this moment, we have a 2-for-1 layout, but we can also change the layouts, and let's use the overlap. That is my preferred one. And we see that and can you give me it here back? And you see that is kind of nicer between our the big one and the little one, picture in picture, etc. And we can do many more things. And let's change again the format, the layout here, and and you can do all those kind of things. I'm not an artist, but if you have ever saw the weekly FreeSWITCH conference, the ClueCon conference call that is on Wednesday, you will see that they use a lot of tricks in computer graphics and things like that. So all in all, the bottom line is we're able to exactly the same code, the same SIP code, both on smartphone app, on browser, and that is able to interact with clients on PSTN and on plain SIP phones from desk phone. And this is using very little CPU and reusing all your existing infrastructure, proxies, servers, and all your knowledge in terms of SIP and routing. The important thing is that we are not inventing a new protocol or some kind of souped up infrastructure that is good maybe for the last mile to reach our users, but it doesn't scale. For example, using alternatives or homemade protocols, then you have big problems into scaling, how you distribute calls between your server farm. And this is solved for free for you from the standard SIP ways to scale, thanks to Kamailio and thanks to 20 years at least of experiences into scaling FreeSWITCH. I'll be back into the dangerous demos later. So hope you had fun, and if there are questions, I'm ready to take them.
Okay, questions? There? No? Okay, so my question.
There's one there.
Why actually the FreeSWITCH has to, you have to put the call on one FreeSWITCH for the conference? Why can't it actually have to be on different ones?
Because conferencing need to actually and materially mix the streams. So for the same conference, the speakers, the ones that want to be on the video, must be on the same box. This do not entail that all the participants to a conference, if you are only an attendee, there is no problem. You can be whatever, and we can route things. But if two persons must be on the same screen and or split screen, this must be on the same box because their video streams must be mixed on that box.
Okay, then let's wait for the dangerous demo and grab Giovanni with the next opportunity in the breaks. So now, Karsten.